Hello students, welcome to the reactive intermediate course. In this lecture we are going to study reaction of benzyne or Arynes intermediates, and we will study nucleophilic addition reaction of benzyne, Diels-Alder 4+2 Cycloaddition reactions of benzyne, and 2+2 Cycloaddition reactions, and finally 1,3 dipolar Cycloaddition reactions of benzyne. My name is Dr. Zulfikar Ali Khan. So let's start our lecture. So welcome to our course reactive intermediate. Today we are going to discuss about reaction of benzyne or Arynes intermediate. So benzyne, its formula is C6H4, and it is and the benzene molecular formula is C6H6. So we can say that benzyne are didehydrobenzene. We can say, in other words, it has two hydrogen less in case of the benzyne. So we can say it is didehydrobenzene. So benzyne are neutral intermediate and they are also aromatic. Criteria for aromaticity is that any compound which obey Huckel rule, which says that the compound must have 4n plus 2 pi electrons, where the n is any number which is starting from 0. So the benzyne, they have 6 electron, so they are according to Huckel rule they are aromatic. So criteria for the aromaticity is any compound which has 6 pi electrons, 4n plus 2, which obey this 4n plus 2 pi electrons, and it is planar conjugated. So another way, benzyne has also one triple bond here, which we can say, if we go into the hybridization, here this carbon make 3 sigma bond. So there are 3 sp2 hybrid orbital. So this carbon is making 1 sigma bond with this carbon through sp2 of orbital of this carbon and sp2 orbital of this to make this 1 sigma bond. This is also making a sigma bond with this hydrogen. So the sp2 orbital of this carbon make the sigma bond with this hydrogen s orbital. So sp2s overlap, and this carbon is also making another third sigma bond with this carbon through sp2 hybrid orbital. So one unhybridized pz orbital is through parallel overlap making this pi bond. So 3 sp2 hybrid orbital on this carbon, they are making 3 sigma bonds. So when we look into this carbon where it is forming triple bond here, the benzyne, in this case this carbon sp2 hybrid orbital making sigma bond with this carbon, and then again this sp2 hybrid orbital is making another sigma bond with this carbon, and this triple bond here, this one, this is the sp2 hybrid orbitals. This is overlap with another sp2 hybrid orbital to make this. This is basically a very weak bond. So this is through collateral overlap, this making interaction make the third here, third triple bond here, third bond. So the benzyne are highly unstable due to this triple bond. They are very strained molecule, so they are highly reactive. So they are going into basically this type of the reactions, nucleophilic addition reaction. They are also going into the pericyclic reactions like 4+2 cycloaddition reaction, 2+2 cycloaddition reactions, dimerization and trimerization reactions, and finally this 1,3 dipolar addition. So these type of the reactions benzyne will give, and we will discuss in detail about these reaction. So this is the first reaction of benzyne, nucleophilic addition reaction. So this is the structure of the benzyne. If we shift this 2 electron over here, we can see we can get a resonance form, 1 2 dipoles, we can write this structure of benzyne in this way. So when we add a nucleophile like water molecule has two parts. It's one is electrophilic part, proton, and other is nucleophilic part, hydroxide ion. So this 1,2 dipole, this negative charge takes this electrophilic part, proton, which comes over here, and this nucleophilic part, hydroxide ion, attacks on this positive end and make this phenol. So this is how the benzyne reacts with the nucleophile. So the same concept is explained over here. When benzyne reacts, this is RxH. We generalize this concept. X is could be any molecule like water molecule, could be alcohol, could be a carboxylic acid, could be thiol, could be amine, primary amine, could be a secondary amine. So when this X attacks, its lone pair attacks here, negative charge shifted here, and then this proton shift occur over here, and we get this substituted benzene as a product. So both concepts, this one or this one, are almost similar. We summarize this concept is also over here. So when this benzyne reacts with carboxylic acid, we get this ester. When it reacts with thiol, we get thioethers. When it reacts with alcohol, then we get this ethers. When it reacts with amine, we get the aniline derivatives. So this is the first reaction, nucleophilic addition to the benzyne intermediate. So when tertiary amine, phosphine and sulfide is added to this benzyne intermediate, here this we generalize this concept. Here the X is sulfur, Nr, or phosphorus, P for phosphorus, and is R. So if tertiary amine, phosphine and sulfide, when with beta hydrogen, this is the beta carbon, so this is alpha carbon, this is beta carbon. So hydrogen attached to this beta carbon are called beta hydrogen. If they have the beta hydrogen, then we form this substituted benzene as a product, and ethene is eliminated. You can see here this lone pair of X attacks on the benzyne. We get here a negative charge here, then this negative charge take this hydrogen, and then this 2 electrons shifted here, and this bond between X and this carbon is broken to form this ethene and substituted benzene as the product. But when these tertiary amine, phosphine and sulfide, they have alpha hydrogen, this is alpha carbon, and the hydrogen attached to this, they are called alpha hydrogen, then we end up with this product ylide. So this lone pair of X attacks on the benzyne, and this charge is shifted. So these 2 electrons shifted here, so we get here a negative here. So this negative takes this proton, and then this 2 electrons shifted on the carbon to form this ylide. Ylide is a type of molecule in which the positive and negative ends are located within the same molecule. So if you studied the Wittig reaction where we form the phosphorus ylide, if you remember. So as we are discussing the nucleophilic addition reaction of benzyne intermediate, so these are some selectivity rule. If benzyne has electron withdrawing group, and this triple bond of the benzyne is present at 2 and 3 carbon, so nucleophile will attack on this position, and this negative charge is stabilized due to electron withdrawing group. So this negative charge is more stable. So this is only one possible product will be formed if this group is changed to electron donating group. Then there are poor selectivity, then both ortho and meta products, substituted products, both will be formed. So if this is electron donating group. So third possibility is that if this group, either it is electron withdrawing or electron donating, if this triple bond of benzyne is present between carbon 3 and 4, then the nucleophile can replace at here fourth position or at third position. Then both meta and para products will be formed. So this effect is less. So therefore effect of this group is less at the when this triple bond of benzyne is at 3 or 4 position. So both the para and meta products will be formed. So this is the regioselectivity rule. When there is a steric factors are involved, steric factors mean the size of the groups. So this is a tertiary butyl group substituted benzyne here. When this reacts with lithium piperidine 1-ide, then this 1,3 tertiary butyl phenyl piperidine, this product is formed. Here this meta substituted product is formed. But when this tertiary butyl, this is a bulky group, so due to the size of the groups, they have the meta product substituted product is formed. But when this tertiary butyl group is changed to this methyl group, this is less bulky, size of this methyl is less as compared to this tertiary butyl group, so we get their ortho substituted product here. So this is the steric factors which controls how the products are formed. So these are the some 4+2 cycloaddition reactions of benzyne intermediate. Benzyne can undergo 4+2 cycloaddition, which is also called the Dizelter reaction. So benzyne behaves as dienophile and reacts with 1,3-diene, and under the thermal condition it form, in this example it form 1,4-dihydronaphthalene. So this is another example in which the benzyne behaves as a dienophile. It reacts with 1,3-cyclopentadiene under thermal condition, and it's form this Dizelter adduct. So these are the two examples of 4+2 Dizelter cycloaddition reactions of benzyne. So these are some more examples of Dizelter 4+2 cycloaddition reaction of benzyne. When the benzyne reacts with this 1,3-diene, here in this case these two methyl stereochemistry is preserved in the product as well, so to form this Dizelter adduct. This is the Dizelter reaction of benzyne with thiophene, and it forms this Dizelter adduct. And this is the Dizelter reaction of 3,4-dimethyl 1-pyrrole with benzyne, and this form this 2,3-dimethyl 1,4-dihydro epiaminonaphthalene. So these are the Dizelter adducts which are formed with the benzyne, and here in all these cases benzyne behaves as dienophile. So these are some more examples of 4+2 cycloadditions of benzyne. Here in this case this is a tetrabromo substituted benzene. It reacts with furan in excess to make this Dizelter adduct. Syn and anti both are formed. So this reaction occurs in the presence of n-butyl lithium, which makes direct lithiation, and then lithium bromide is eliminated to form the benzyne on both sides. So this then benzyne act as dienophile and reacts with this furan to form the syn adduct as well as anti adduct. So this is the benzyne reaction with furan 4+2 cycloaddition reaction. So it forms this 1,4-dihydro 1,4-epoxy naphthalene. This is the Dizelter adduct. And then this is the 4+2 cycloaddition of anthracene. This middle ring of anthracene behaves as diene, and this benzyne act as dienophile, and it forms this Dizelter adduct. So this these are some more example of 4+2 cycloaddition of benzyne intermediate. So this is the 4+2 cycloaddition of benzyne with this tetra substituted cyclopentadienone to form this diazotyl reduct. This diazotyl reduct with the loss of this carbon monoxide, it aromatization occur and it forms this substituted naphthalene derivative. So previously we discussed 4+2 diazelder reaction of benzyne intermediate. So now we are discussing, in this lecture we are discussing about 2+2 cycloaddition reactions of benzyne intermediate. So this is the first reaction. Benzyne reacts with ethene in the presence of, it is light. It's formed this cyclic transition state. This dotted line shows that these new bonds are formed here, and this one old bond is broken. So it formed this, after 2+2 cycloaddition formed this product. This is a bicyclo. It has 2 cycles. So how we name this compound? It's these are the 2 bridgehead carbons. We start the numbering from 1 bridgehead carbon in such a way that maximum number goes to the other bridgehead carbon. So we start here with 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 members, therefore we used here octa. And then if you see in the bridgehead how many carbons, there are 4 carbons on this side, 2 carbons on this side. Between the bridgehead 0 carbon, so we use here 4.2.0 octa 124 triene. These basically these 1, 2, 4 triene. So this is the second example of the 2+2 cycloaddition. Malic acid, it reacts with the benzyne intermediate, and it's in the presence of light, it forms this product. This is again the bicyclo 4.2.0 octa 124 triene 7,8. At 7 and 8 position, 2 carboxylic moieties, 7,8 dicarboxylic acid. So this is the third example of 2+2 cycloaddition. This one in the presence of light, after loss of carbon dioxide, this produces benzyne, and then this reacts with trans 1,2-dichloroethene. So it's formed this product here. This chloro moiety, this is R configuration, whereas this one is above the plane or maybe behind the plane. So both type of the mixture of products will be formed. This is another example of 2+2 cycloaddition reaction of benzyne. It reacts with this 7-member 1-heptene with this double bond. It may react with this allylic position, allylic hydrogen, or it reacts with 2+2 cycloaddition. So this is a major product is formed when this reacts here at the allylic position, and this is a minor product which is formed due to 2+2 cycloaddition reaction. So this is the dimerization reaction of benzyne. Dimerization of the benzyne is very common. In this case, the benzyne reacts with the other benzyne through 2+2 cycloaddition to form this dimer product. So this is the dimerization. Next is the trimerization of the benzyne intermediate in the presence of transition metal like this palladium tetrakis. So this transition metal, in the presence of transition metal, this trimethylsilyl, and this is a good leaving group, and this is trifluoromethyl sulfonyl triplet. So this starting material produces benzyne like this, and then this benzyne undergo 2+2 cycloaddition to form this polyaromatic hydrocarbon triphenylene. So this is the trimerization reaction of benzyne in the presence of transition metal. So this is the last and final reaction of benzyne. This is 1,3 dipolar cycloaddition reaction. So benzyne it reacts with this benzo nitrile oxide. This is 1 2 3. This is 1 3 dipole. So it reacts to form this very important class of heterocyclic compound. This is 3-phenyl benzoisoxazole. So this is phenylazide. This phenylazide, this if you count 1 2 3, this is 1 3 dipole. So this phenylazide reacts with benzyne and to form this 1-phenyl benzotriazole. This is also another important class of heterocyclic compound. So this is the last and final reaction of the benzyne, which is the 1,3 dipolar cycloaddition reaction. Here we discuss two examples of 1,3 dipolar cycloaddition reaction.